Okay, let's talk about an application that you actually run on your computer, like the Atom Editor or Slack. It's got a nice bar over here with a bunch of menu items. Okay, and it's got a chat box down here where you can enter something in, and a send button here. Okay, so we have some sort of an application. Now, it used to be that the way that these applications were written is they actually built a piece of code that ran on your computer that was for your computer, which means it had to use the graphical user interface of your computer. And when they went to build it for, say, they built it for a PC and later they wanted to do it for a Macintosh, about 2/3 of the code in the application would have to be tossed out and completely rewritten from scratch. It was a huge undertaking to port applications. These days what they do is this is actually just a web page, and on your computer it's running and there's a server on your computer, and that server talks to the web page, usually over a socket connection, so it's bidirectional. But basically all this is a web page. And that server then can do things like save files on your computer and work with the stuff on hardware on your computer. But basically, you're looking at a web page, then this guy, if it talks to some remote location like Slack does, it sends messages, goes out and talks to the web out there. And it knows how to talk to its servers in the web, but you click on the desktop, a thing comes up, but what really happens is two pieces come up, not just one. And why did this come about? Well, not only does that mean that this application is now portable, but for all practical purposes, this is just a web page, which means that not only is this portable, but there's only a little piece of it in here, about 5%, that is dedicated to being the desktop application. And the rest of all of it, and there's a little piece in here that is also dedicated to being a desktop. Okay, so these little pieces. The rest of all of this code is the exact same code that you would run if you brought it up in a browser. So you bring up your browser, you type in Slack as an URL at the top, and it brings up the same application, okay, with the same stuff. Except now the server is, here's your cloud to the internet, it's talking this way, and the server is on the far side. So this piece moves over here, but the same code. And almost no changes. So comparing this to building an actual desktop application, if a desktop application, I'm talking like a Windows Foundation application or a Cocoa application on a Macintosh, if that took 10 units of time, then this will take 1 to 2 units of time. Most of it is reusable. So basically, building now a desktop application takes 2% of the amount of time that it used to take. And when you go to update the application, it's not a big, heavy process to do. All you have to do is have some update code in here that knows how to pull in a new copy of the application. And it's done. There's no installation, security, signatures of applications. How does the person find it? Where do they install it? Do they install all the options? Do they have the correct libraries? All that stuff is gone. And what you have is a browser-based application. Now, you can build some pretty fancy browser-based applications. And to give you some kind of an idea of how fancy, look at the Atom Editor, which is a desktop editor for code development. And look at Discord. That is another one of these. You install the application. Discord is one of these browser-based applications. So this kind of technology with cascading style sheets, HTML pages, servers, and how they work is the primary architecture that you see for almost all applications these days. And because these servers are relatively easy to build, I say relatively, there are already pre-existing servers that you can basically just attach the pages to and attach the content to, and you don't have to do any of the work inside here. Okay, because those are easy to build, you buy a router. And a router is a little tiny box with a processor in it. It's got some dedicated software on how it routes. But guess what they're going to put on it for a user interface? They're going to copy in some files and they're going to put a server on it. So you want to configure your router, you bring it up in a web page. And you have some IoT device, like that light bulb up there that I can connect to. it has a web page. And that means it talks over the web using this kind of technology. So even little tiny computers like the one in the light bulb, they all work off of web pages and servers. And you just don't see much being done in terms of actual desktop applications. The exceptions are things that have to have high security sometimes, but I think that's fading into the past. Not the security, but doing it this way, because there's a thing called WebAssembly that's going to allow you to build high security applications for this kind of a model. And collectively, this is the architecture that we're building for, this distributed over-the-web server-based technology with a rendering document and its rendering information, a server that responds to communication endpoints wherever it sits in the stack, and consequently you go, why would you build something for a Microsoft platform? I mean, it used to be that they built Microsoft applications because, yeah, they were the most common and that was the way we built stuff, and then if you had to, you ported it to a Macintosh. And most things didn't get ported. But these days, you build one of these things. It works on the web, it works on most desktops, it'll work on things you haven't even thought of, and boom, you're done with a little bit of work. And that little bit is not complex. So this is the architecture for most applications. Now you go, what about an iPhone? Well, let's do a little iPhone app here. We'll give it the little notch at the top and you click on it and run it. Now in between, I'm going to draw a little ziggly thing here. There is your cell provider. Okay? But basically, your iPhone, when it communicates, okay, some stuff happens in between, but guess what? It goes up here in the frame cloud and comes out just like any other application. And almost all applications built for a phone or a mobile device or an iPad communicate in this fashion. They're using the same technology as everything else. Now, mind you, there's some compression and there's radio signals and there's towers out here with antennas and computers and more stuff in between, and boop, out it comes on the other end. So there's some unreliable stuff in here. I say unreliable because radio signals, you've had a call drop on you before, you know they're not reliable. But basically, yeah, it looks the same. And all of these guys are all communicating with HTTP and WebSockets and making this happen with all of the web technology. So this is the world of applications today, not anything else. And notice something about this world of applications. Although we have some desktops like Windows running a browser, there's nothing tying you to Windows in any of these cases. So Windows has lost its development advantage. And most of these things, all the stuff in the frame cloud, I wouldn't say all, but almost all the stuff in the frame cloud, the servers, okay, the pieces in between, all of these guys out here, all this communication, all the routers, all of those guys, they're all running various forms of Unix. And most of those, if you actually want to connect to the computer, they don't have any other way to connect other than a server that serves up files and content and responds to stuff, or you log into the command line. So most of this is command line usage. And when we look at our tools like VS Code, it gives you a nice drop-down GUI and stuff and debugger, and down there on the bottom when you run something, it runs a command line. So command line usage is something we're going to talk about and how it relates to this, but this is kind of the big picture of how applications work together these days and why they are built the way they are.